Hi, thank you for joining. I'm sorry with all the different IT issues. So as Kara, I think, just said in Korean, I will start with the company presentation, and then Kara will help a bit with translation. After that, we'll run the demonstration on a video that was recorded a couple of days ago because of time zone difference. And then after that, we can discuss questions that you may have. So let me start with the company presentation. Can you see the slides first? So Teledyne E2B is part of a company called Teledyne Technologies, which is a large company with a multitude of products in different markets. That's a conglomerate of maybe 60 different entities and brands. And we're part of this company.
네, 저희 텔레다인 E2V는 텔레다인 테크놀로지의 이제 그 한 엔터티고, 저희 텔레다인 테크놀로지는 약 60개 그 회사들이 있습니다. 그리고 저희는 이제 그 텔레다인 E2V 회사이고, 다양한 디퍼런한 테크놀로지로 다양한 그 제품들이 있습니다.
Okay, so a bit more overview on the different markets and products that we develop. So starting on the left, we do a lot of image sensors for machine vision applications. So that's sensors, cameras in both visible, infrared, UV, and X-ray wavelengths. We do also RF products, which target more medical application, and in particular radiotherapy. The third one in aerospace and defense, that's the one we are mainly focusing on today with the demonstration. But so for this, we have also image sensors, but a lot of semiconductor products with high ability performance as well. Fourth one with Geospatial, this is more LiDAR, sonar systems, so it's more for mapping, cartography. There are also some application in movies, 3D rendering, for example. The fifth one is more specific foundry capabilities in Canada and in UK, not really the focus for today. And the last one, scientific, it's more advanced scientific equipments to support research in different domains.
예, 저희가 이제 포커싱하고 있는 그 마켓에서 설명을 드리겠고요. 일단 저희가 텔레다인 이미징 그룹에 있고, 현재 이제 머신 비전 쪽에 이제 포커싱을 하고 있고, 이제 메디컬 앤드 라이프 사이언스는 이제 RF 이쪽에서 메디컬 쪽에도 저희가 포커싱을 하고 있고, 에어로스페이스 앤 디펜스, 저희 이제 텔레다인 E2V가 속해 있는 디비전이고요. 저희가 주로 이제 스페이스 앤 디펜스, 사이언스, 그리고 하이 릴라빌리티 제품에 포커싱하고 있습니다. 그리고 옵텍이라는 그 지오 스페츄럴 쪽에 이제 3D 쪽으로 매핑 쪽에 있고, 세미컨덕터 쪽은 저희가 이제 다양한 MEMS 파운드리, CCD 파운드리 서비스를 하고 있고요. 그리고 사이언스틱 이미징 쪽에도 저희가 포커싱하고 있습니다. 이쪽은 주로 텔레스코피, 마이크로스코피 쪽에 포커싱을 두고 있습니다.
So let's focus a bit more on Teledyne E2V with this slide. So we have three main business units. The first one is imaging with professional and space image sensors. And here you have a couple of examples. So the first one, we have a lot of equipment that use our cameras to inspect food, for food inspection. And the second one is in space, where we also supply a lot of image sensors for Earth observation satellites. The second one here that we call RF power, they develop high frequency, high power system, which are used in radiotherapy machines, and we have a very high market share in that market. So we're helping doctors treat cancer patients with our product. And the last one, semiconductors. So that's the one Kara and myself are working in. We develop microprocessors and data converters for high availability applications. So microprocessors specifically, we provide them to a lot of avionics customers to go into flight computers for different needs in commercial airplanes.
저희 E2V를 텔레다인 E2V 소개해드리면 저희가 이제 세 개의 비즈니스 디비전이 있어요. 저희가 이미징 디비전 쪽에 있고, 그래서 이제 주로 포커싱하고 있는 곳은 인더스트리얼 어플리케이션, 그리고 그래서 주로 이제 그 푸드 인스펙션 이런 쪽에 포커싱을 두고 있고, 다른 또 이제 그 어플리케이션 쪽으로는 주로 저희가 스페이스 쪽에 이제 포커싱하고 있어서 스페이스 어플리케이션은 위성 쪽에 디텍터뿐만 아니라 사이언스 쪽에 디텍터를 공급하고 있습니다. 그리고 저희 RF 파워 디비전이 있는데요. 하이 프리퀀시 더 RF 솔루션으로 저희가 주로 이제 캔슬 그쪽에 트리트먼트하는 RF 솔루션 갖고 있고, 그리고 또 RF 이쪽에도 디펜스 쪽에도 저희가 다양한 비즈니스를 하고 있습니다. 그리고 세미컨덕터 쪽은 저희 이제 마크와 저희가 속해 있는 그룹이고요. 저희가 주로 이제 마이크로 프로세서, ADC, DAC를 생산하고 있고, 주로 이제 포커싱하고 있는 마켓은 이제 스페이스, 디펜스 쪽에 이제 하이 릴라빌리티 제품을 공급하고 있습니다.
So let's focus on the processors, which is the demonstration of today. So for processors, we are providing high performance, high availability processors, and that's based on a partnership we have with NXP. So NXP is a company based in US that develop a lot of products, but in particular processors for networking, telecommunication applications. And so we have access to these products and we upscreen them to higher ability markets, so aerospace and defense.
네, 저희 오늘 소개할 제품은 이제 프로세서 제품이고요. 저희 이제 텔레다인 E2V가 포커싱하고 있는 마켓은 하이 퍼포먼스, 하이 릴라빌리티 이쪽에 하고 있습니다. 그리고 NXP는 그 US 회사고요. 주로 이제 네트워킹이나 텔레커뮤니케이션에 집중을 하고 있고, 저희가 이제 NXP 프로세서를 가지고 저희가 하고 있는 부분 이제 하이 퀄리파이드 하이 퍼포먼스 쪽에 저희가 이제 하고 있고, 이제 NXP와 오랜 파트너십을 가지고 일을 하고 있습니다.
Okay, and then the last slide before we go into the demonstration. So this one, there's a lot of information. The only thing I want really to underline here is this bullet point, which is introducing a bit what the demonstration shows. So one of the capability we have on these processors is to do specific testing in order to improve power consumption or other parameters. And that enables our customers to have access to very high performance processors while also optimizing specific parameters to match their very constrained requirements for their embedded systems.
네, 오늘 저희 마이크로 프로세서에 대한 간단한 저희 캐파빌리티 서머리고요. 오늘 이제 저희가 포커싱하고 있는 것은 마크가 이제 빨간 쪽으로 포인트한 Extended Temperature Range Customized Screening 이쪽에 오늘 데모를 할 거고요. 저희가 이제 고객이 요청하는 이제 그 스펙에 따라서 이제 저희가 업스크린을 진행하고 있고, 저희가 주로 이제 파워 컨섬션, 프리퀀시 이쪽에 고객의 요청에 따라 저희가 스크린을 하는 그 서비스를 제공하고 있습니다.
So let's move on to the video demonstration. So as we just shared, this is demonstrating our power saving capabilities by comparing one processor using standard testing and one processor in specific conditions and testing that is our added value.
오늘 이제 저희가 그 파워 세이빙 데모를 할 거고요. 저희가 이제 스크린한 제품과 이제 보통의 제품을 가지고 비교하면서 저희 이제 파워 세이빙 하는 쪽에 대해서 이런 장점들을 보여드릴 계획입니다.
Welcome everyone. Today I'd like to exhibit a demonstration that we have put together to show you in practice how you can save power and simplify thermal management in high reliability processing systems so that you can see with your own eyes the possibilities that we offer at Teledyne E2V. At Teledyne E2V, we receive frequent customer requests to deliver power-optimized processors. Sometimes the need is to reduce power consumption because of power supply sizing or because of limited power available. In drones application, for instance. Sometimes the requirement is of compactness because it's not possible to cool properly the components within the given volume constraints. A few months ago, we published a white paper that explains in detail how we managed to reduce by 46% the power consumption compared to the datasheet power consumption on a specific customer application. Today, I'd like to show you in practice the benefits that it brings. Before going in the details of our demonstration, I would like to give you some details on how to analyze processor power consumption. Processor power consumption is typically split between what we call static power consumption and dynamic power consumption. So on this graph, dynamic is the yellow one and static is the blue one. What you have to know about static power consumption is that it more or less corresponds to the leakage current that is flowing through the device as soon as you apply power supplies on it, even if in reset state and even if there's no clock applied. Static power consumption evolves non-linearly versus temperature. And what's interesting about static power consumption is that it's not repeatable across parts. That means it's possible to select parts that have lower power consumption. Dynamic power consumption, on the other hand, is more or less independent from junction temperature, but it is dependent on CPU load, platform and CPU frequency, and the types of peripherals that you are using. That means that dynamic power consumption is dependent on your application. Now, let's go in the details of our demonstration. We have two single-board computers that have been designed by our partner Syntex. On each single-board computer, we've got a T1042 processor that is a quad-core PowerPC architecture that can run up to 1.5 GHz. The left processor is a standard processor that is running an application that loads the CPU at 100%. The right processor is a Teledyne E2V power-optimized processor that runs an application that loads the CPU at 50% load. We've got an infrared camera from our colleagues at Teledyne DALSA that is looking at both processors simultaneously, and the camera picture is displayed on this screen. So we've got still on the left the standard processor and on the right the Teledyne E2V power-optimized processor. So now looking at the details of the results. So if we look at the left processor, we've got the temperature, the heatsink temperature is around 71 degrees and the right processor is around 59 degrees, so around 12 degrees of difference. As you've probably realized, the junction temperature is actually higher, and this is what we see on the terminals. We see that the processors are between 90 and 100 degrees of junction temperature. So there is still a very big difference in terms of junction temperature between both processors. Looking at the junction temperature and the board power consumption, so board power consumption, we've got 10 watts on the left board and we've got around 9 watts on the right board. And if we look in the details of the processor power consumption, which is of interest here, we see that the difference between the two processors is between 1.5 to 2 watts, which is quite a very big difference. So, to conclude today, what we have shown is how it's possible to reduce power consumption in your high reliability processing system thanks to our products. What we have shown is when keeping the same heatsink, it's possible to reduce power consumption. but it's important to note that it's also possible to reverse the approach and to keep the power consumption fixed and to reduce the heatsink size. If you want to get in more technical details on how power-optimized processor products can help you, don't hesitate to have a look at our white paper and to get in touch with us.
Yesterday, so we will do that. And then if you have any more questions, feel free to contact Karen and myself, and we'll be happy to answer.
좀 더 알고 싶은 부분이 있으면은 이제 마크랑 저한테 컨택하시면은 제가 이제 좀 더 자세히 좀 놓친 부분에 대해서 설명을 드릴 수 있을 것 같습니다.
Yep, thank you. 감사합니다.